Okay, hello everyone, it's Salar and we are in part 55 of our tutorial to writing a real-time operating system. In previous part, I did the implementation of semaphore, okay, a locking mechanism. But in this part, I want to talk about another locking mechanism, Mutex. And directly in this part, I want to start to implement Mutex because concept of Mutex is like semaphore. Mutex like semaphore is a locking mechanism. Okay, in this part I want to implement Mutex, but Mutex or mutual exclusion or Mutex. I'm more easy with Mutex. Okay, Mutex. I want to say that Mutex. Mutex is a lock mechanism like semaphore. Okay, but what is the differences between Mutex and semaphore? First, maximum count of Mutex is always 1, like binary semaphore, okay? The maximum count of Mutex is always 1. So Mutex has two states, unlock or 0 and lock or 1. Okay, so first difference, count of Mutex is always 1, but count of semaphore can be more than 1. Okay, after that, Mutex has an owner. What is owner? The thread that has gotten the Mutex, that got the Mutex. Okay, for example, in this example, when thread function 3 get this Mutex, if return value if return value is okay, now the owner of this Mutex ID 1 or Mutex 1 is thread 3. Okay, the thread that got the Mutex, and in the last, just owner this thread can release the Mutex. In semaphore, all of threads can release a semaphore, but a locked semaphore, okay? Release a locked semaphore. But in Mutex, just the owner can release the Mutex. So let's go to implement the Mutex. Like thread and semaphore and kernel, you need a Mutex, you need a control block. At this time, Mutex control block and a structure. First member, an ID. Address of Mutex control block has been written in ID. Okay, name, like thread and semaphore. Lock is equal to count. Okay, but maximum value of lock is always 1. Okay, the count of Mutex lock is count of Mutex. When the lock is 0, Mutex is unlocked. When the lock is 1, Mutex has been locked. Owner, I said, what's the owner? The thread that got the Mutex, a thread ID. Okay, you must write the ID of owner in this member. I will talk about this member in next slides, but Mutex wait list, like semaphore wait list of those threads, that have waited for a Mutex, and a resource state. What is a resource state? After creating of Mutex, the value of this member is active. Okay, but after deleting the Mutex, RTOS write deleted in this member. Okay, it's a simple member. Okay, shows the state of Mutex. So like semaphore waitlist, Mutex has a Mutex waitlist. Another time is a binary tree, and all of nodes have ordered according to its priority. Okay, the rightmost node has the most prior thread in this list. But to support Mutex, you must add some members in thread control block. First, Mutex wait node. When you want to insert a thread to this list, thread needs to have a node, okay, a binary tree node. Mutex waiting for. When RTOS insert a thread to Mutex wait list, for example, Mutex wait list, write the ID of the Mutex in this member, like semaphore, and thread owned Mutex list. What is this list? What is this data structure? This data structure is a simple queue. Okay, but thread owned Mutex list. When a thread owns or gets a Mutex, RTOS inserts that Mutex in thread owned Mutex list. List of all of owned Mutex by a thread. Okay. Owner of all of Mutexes in this list is this thread. Okay, for example, when thread 1 gets Mutex 1, RTOS insert this node in this list. So because you want to insert Mutex in this list, Mutex needs to have a node. Okay, and this member is thread owned Mutex node. Now everything is okay. Let's talk about system calls of Mutex. To implement Mutex, I implemented these system calls for the RTOS. First, Mutex it doesn't need to see. Mutex get name, like thread get name or semaphore get name. By using a Mutex ID, you can acquire the name of the Mutex, this Mutex, okay? Mutex create new. Sorry, it has two arguments. Another argument is type. Okay, another argument is type. And I missed that. Okay, Mutex create new needs two arguments, name and type. In other operating systems, Mutex has two types: single shot and recursive. But in first version of our RTOS, the RTOS, I've just implemented single shot. Okay, but in next version I will update the RTOS and I will implement recursive Mutexes. Okay, so when you want to create a Mutex in this version, always you must write Mutex type single shot in second argument. Okay, but in next version I will implement recursive Mutex too. Okay, but what does Mutex create new do? Just initialization the Mutex control block. Okay, let's see the Mutex control. Mutex create new. Here you can't call Mutex create new from interrupt. like other system called write types in structure and call kernel system call. But at this version, the type is not important. This function write Mutex type single shot in type argument, okay? But in next versions of the RTOS, I will support Mutex recursive, and in next version I will say what is the differences between single shot or recursive, okay? But Mutex create new system call, kernel space system call. First, allocate memory to Mutex control block and write the address of Mutex control block in ID, okay? After that, initialize the name. After that, initialize the count or log by Mutex unlock, okay? And set the type Mutex single shot, okay? It's not important what is the argument. Always in this version, set the type and initial the types like here by Mutex type single shot. And owner at this time is null. Owner at this time is null because at this time the Mutex isn't locked by a thread, okay? And initialize Mutex waitlist and initialize thread on the Mutex node, okay? Initialize this node, okay? And change the value of resource state to active. This member shows the Mutex has been created, okay? When you want to delete a Mutex, you must change this state to deleted, okay? Now, Mutex has been created, and this is create new, Mutex create new, Mutex create new. After that, Mutex delete, a simple function because deleting a locked Mutex is impossible. Deleting a locked Mutex is impossible. So to implement this system call, first, you can't delete a Mutex that has been deleted, okay? If a state is deleted, you can't delete a deleted Mutex, okay? And you can't call this system call from interrupt. All the parts is like other system calls. But first, you must check when you want to delete a Mutex. RTOS first, check the lock member. If Mutex has been locked, return error. Otherwise, write deleted to the resource state and free name thread owned Mutex node and Mutex waitlist. But this function don't free the Mutex control block, okay? Mutex control block structure. But this is a simple sorry, this is a simple system call. After that, let's talk about Mutex get. Like semaphore get, I have a chart. Let's inspect the code by using of this chart. When a thread wants to get a Mutex, RTOS do some actions according to this diagram. Let's inspect this diagram. First, check the lock member. If Mutex is unlocked, if the resource is free, RTOS first lock the Mutex and set the owner. Caller of Mutex get. You can get a first sometime you can get a deleted Mutex, okay? After that, in kernel space system call. First check lock. If unlocked, lock the mutex, change the owner to the color, okay, color of this system call, the thread that's called this system call, that's called the system call, and after that insert this mutex, to the color owned list, okay, to this list. Insert mutex to this list for the color thread. Okay, set owner and return status okay. Otherwise, if mutex has been locked and mutex is locked, first compare the color by owner of mutex. A locked mutex has an owner. If color of mutex is owner of mutex, you can return OK. You can get a mutex by a thread more than one time, okay? Return OK. If the color of mutex is owner of mutex, return OK. Otherwise you can't get the mutex because mutex has been locked and color is not owner. At this time, check timeout. If timeout equal to 0, immediately return error. If the timeout is 0, immediately return error, like semaphore. Otherwise, put the thread in mutex waitlist. Okay, put the thread in mutex waitlist, completely like semaphore. First insert color of mutex get to the mutex waitlist and change mutex waiting for in thread control block to mutex ID. Now color mutex color waited for this mutex. After that, delete color from ready list and insert it to waitlist by using of this waitlist number and return tick. And like semaphore get, at this time unset return by release in thread control block, okay, completely like semaphore. If you want to comprehend this line and if you want to find what is the responsibility of this line, refer to previous part, implementation of semaphore. It's completely like implementation of semaphore, okay. And after that, after deleting a thread from ready list, if context switch is necessary, request for context switch, okay. And after deleting, after returning to mutex get from kernel space by using of return by release and return value, status wait, or other return values, acquire the return value. If thread returned to ready list by using of mutex release, the status is okay. But if thread returned to ready list from waitlist to ready list by using of kernel waitlist handler, the status error timeout. Otherwise, return the return value. If it's not inserted in waitlist, return the return value, okay. Completely like semaphore get. So easy like semaphore get. And after that, let's talk about mutex release. Let's inspect code by using of this schematic, this chart. like Mutex get. First check lock member. If Mutex is unlocked, you can't unlock an unlocked Mutex. Okay, return error. Semaphore release. First, you can't release a deleted semaphore. Okay, if the state of semaphore is deleted, return an error. And you can't call Mutex release. You can't release a deleted Mutex. Sorry, a deleted Mutex. And you can't call Mutex release from interrupt. Other parts of code, it's like other system calls, user space system calls, but in kernel space system call. First, check the Mutex. If Mutex is unlocked, return an error, because you can't unlock an unlocked Mutex. Okay, otherwise, if Mutex has been locked, first compare color of Mutex release by owner of Mutex. Mutex has been locked, so Mutex has an owner. Compare color of Mutex release by owner of Mutex. If color of Mutex release is not the owner of Mutex, you can't release the Mutex. I said in this slide, just owner can release the Mutex, a locked Mutex. Okay, if color is not owner, return error. Here, if Mutex owner is color and else, here else. If Mutex color is not Mutex release color is not the owner of Mutex, return error. Okay, otherwise, if the color of Mutex release is the owner, you can release the Mutex, but first check Mutex wait list size. If the list size equal to 0 and there is no thread in Mutex wait list, just unlock the Mutex and set the owner to the null. Okay, because an unlocked Mutex has no owner, doesn't have owner. Okay, if before checking this, if you must delete Mutex from its owner list, Mutex from owner list of this thread. Okay, color thread is owner thread. Delete this Mutex from thread owner Mutex list. From this list. Okay, first delete Mutex from this list after releasing. And after that, check the size of Mutex waitlist. If the Mutex waitlist is free, unlock the Mutex and change the owner to the null and return the status okay. Otherwise, return most prior thread and change the owner. Return most prior thread completely like semaphore. Okay, get max to acquire the most prior thread in binary tree. Now, new owner of Mutex is weighted thread. This weighted thread, put the Mutex in Mutex list of the thread, weighted thread, and now owner of Mutex is weighted thread, most prior thread in Mutex wait list. And delete the weighted thread from Mutex wait list. and change this member in thread control block to null because Mutex color. Oh, sorry, this is wrong. This must be wait thread. This must be wait thread. Sorry, I must change the code in GitHub. This must be wait thread. Wait thread at this time. Wait thread has not waited for Mutex anymore. Okay, because wait thread acquired the Mutex is most prior thread. Okay, I must change this line in GitHub too. Okay, and resolve this problem in my code. Okay, this must be wait thread. Okay, so and after that do it wait thread from wait list and insert it to read list and set this value to return by release set to 1. Okay, like semaphore. To comprehend this line, refer to semaphore implementation part, previous part 54. Okay, so very good. Let's see an example another time. Compile the project and see an example. Okay, now let's run this example. Before that, like before, I have 3 threads, thread 1 and thread 2 with priority normal, and thread 3 has priority high. I have a semaphore. Its max count is 2, initial count is 0, and a Mutex. The name of Mutex is Mutex 1. The type is single shot. At this version, you just have single shot type. Okay, you must write this argument here at this version, but in next versions I will support another type too. Okay, and another type is recursive, and in next versions I will say you what's the differences between single shot and recursive. Okay, but if I want to be more exact, this implemented Mutex is neither single shot or recursive. It's between single shot and recursive. Okay, but in next versions I will implement single shot and recursive like other RTOSs. Okay, but at this time it's not important. It can be used for locking resources just like other Mutexes in other operating systems. Okay, but when you want to create a Mutex, you can't create your Mutex by using of this function. Okay, but because thread 3 has higher priority than thread 1 and thread 2, at the first step RTOS jump to thread function 3, and now I want to get the Mutex for the thread. Okay, now Mutex has been gotten and the return value is okay. Okay, now I want to get semaphore 2. Okay, but the initial value of semaphore count is 0. If I run this code, RTOS jump to thread 1 and insert thread 3 to the wait list. Now in thread 1 I want to release the Mutex, but the owner of Mutex is thread 3, and thread 1 can't release the Mutex. If I run Mutex release, the return value will be error resource, and thread 1 can't release this Mutex, but thread 1 can release the semaphore. because owner in semaphore is not important, and semaphore has no owner. Okay, it doesn't have owner. If I release this mutex, immediately RTOS return to thread function 3. Okay, because thread function 3 has higher priority. Okay, after releasing, jump to thread function 3. Okay, and return value of mutex get is okay. Okay, because thread 3 has been returned to ready list by using of semaphore release. Has been returned to ready list by using of semaphore release. So now thread 3 get semaphore like mutex. Okay, now I want to release the mutex in thread 3. Return value is okay because owner of this mutex is thread 3, and thread 3 can release the mutex. So very good. But before to finishing this part another time, like semaphore, if you want to support mutex, you want make a little change in waitlist handler, like semaphore. In kernel, you must add these cases for when you want to create a new system call like other system calls, and in kernel waitlist handler you must insert these lines in the code. If thread waited for a mutex, okay, and its timeout has elapsed, kernel waitlist handler first must delete thread from mutex waitlist and change this member mutex waiting for to null and return the thread to the ready list after finishing the timeout, like semaphore. Okay, so very good. This part was the implementation of mutex, a locking mechanism like semaphore. Very good. Thank you very much to see me, and see you soon in the next part.